All right, so look at example 3, guys. How's this one different than the others? It's got more fractions in it, right? So now we're really going to have to find the least common denominator. Now, granted, I could multiply by all of the denominators, but that's going to be a lot of x's. And so then I'm going to run into trouble when I'm trying to factor. So we need to find the least common denominator for this one, and that's what we're going to multiply by. So first thing we're going to do to find the least common denominators, I got to make sure all of my denominators are factored. So look at your first fraction. Its denominator is x. Can I factor that down any further? Okay, the second fraction. Its denominator is x minus 1. Can I factor that down any further? What about the third fraction, the x squared minus x? Yes, I can common factor it. What can I take out of it? An x. And so when I take that out, that leaves me with x minus 1. So we find that it's x times x minus 1. Now, when I go to find my least common denominator, I just work my way, this is my method, is I just work through my fractions. So I look at my first fraction and I say my least common denominator has to have that x in it, does it? Well, I don't have anything in it right now, so obviously not, so put the x in it. And then go to your next fraction. It has to have an x minus 1 together because the minus sign is like super glue. Remember we talked about that before? It holds it together. So it has to have an x minus 1. Do I have an x minus 1 in it? No. So put it. And so put it in parentheses so we know that it's together. And then check your last fraction. It's got two different things in it. It's got an x. Do I already have an x in it? Yes. It also has an x minus 1. Do I have an x minus 1 already in my least common denominator? Yes. So that means then that x times x minus 1 is the least common denominator. And so I'm going to take that and I'm going to multiply all of my terms here by it, including the 0 there on the end, okay? It wasn't a fraction, so I didn't have to worry about talking about least common denominator with it, but it still gets multiplied by it. If not, my equation could come out wrong. This one being a 0, honestly, it's not going to make a difference, but if it was a different number, it would make a big difference. So I'm going to write it out. So I have the x plus 2 over x times x minus 1. And then there was a minus sign. 4 over x minus 1 times the x times x minus 1 plus 2 over x times x minus 1 times the x times x minus 1. Uh-oh, I'm running out of room. Equals 0 times the x. Oops, let me put the 0 in parentheses, sorry. Times the x times x minus 1. So then we're going to start canceling. So this first part, my x's are cancel, and I'm left with x plus 2 times x minus 1. Minus. Then my x minus 1's cancel, so I'm left with 4 times x. Plus. The x's cancel and the x minus 1's cancel, so I'm just left with 2 equals, and then this, what's 0 times anything? 0. Now what can we do? What's that? Foil. Yeah, we can do FOIL. So here we're going to do FOIL. And then I have minus 4x plus 2 equals 0. And I didn't combine my like terms in my FOIL yet because I'm going to combine like terms anyway, so I might as well just do them all together, right? So now I'm going to combine like terms. So I have x squared. But then I have negative x plus 2x, which is minus 4x, which is good. And then I have negative 2 plus 2, which is, okay, so I'm not going to put it, and it's equal to 0. Now what? I'm sorry? I didn't hear you still. I'm sorry. I got to solve. Good. How? Yeah, I can common factor out an x. And then set them each equal to 0. And then what do we need to do? Check it. Okay, I got the x times x minus 3 because I took an x out of both of these. That's where the x in front came from. And that left me with x minus 3 inside. It's a common factoring. Okay? Alright, so I'm going to check when x equals 0. So I'm plugging it into the original. Oh no, what is that? What did I just write? 0 plus 2 over 0? Can I have 0 on bottom? Oh, so this one's not going to work automatically because I can't have 0 on bottom of my fraction. So that one's out. So I didn't have to finish that check. I caught that. It's a restriction, isn't it? It's not in the domain. And I'm going to talk about that in just a minute here.
It's a hole.
No. Wait. Actually, maybe. Yeah, you made me think. No, I don't know. All right, so let's check the... I didn't finish. I didn't finish that one. What was x on the second one? Yeah, I had the 3. I didn't finish working this one. So x equals 3. Now I need to check it. I'm going to move up actually a little bit there. I'm probably going to need more room. So I'm going to plug it in the original. And so I'm going to work on this first fraction. So I get 5 over 3. Second fraction, it's 4 over 2. Plus the third fraction, there's 2 over, is that 9 minus 3? So 5/3 minus 2 plus 2 over 6. Which is 1/3. Okay. Well, can I go ahead and add the fractions together since they have a common denominator? What's 5/3 plus 1/3? 6/3, which is minus 2, which is, I ran out of room, so I'm just going to put it there. And isn't that what we wanted it to equal? So 3 is my solution. Now, they told us we had to check our answer. But guys, I think there's an easier way. We already know how to find the domain, don't we? How do you find the domain of a fraction? Yeah, the denominator cannot equal 0, right? Well, my denominator is really that least common denominator. So if I want to know if a x value cannot be my answer, it just can't be in the domain. So when I find my least common denominator, if I go ahead and find those restrictions, and one of those restrictions is my answer, then I will know it can't work. So just like on this one here, I'm just going to do it real quick up here. I'm back up, where it says least common denominator up there at the top. I'm going to put a little green star up there. If I would have said, okay, then I know that the restriction is that x times x minus 1 cannot equal 0. That would have told me x cannot equal 0 and x minus 1 cannot equal 0, which would have meant x could not equal positive 1, correct? And so I would have known if I got x is 0 or x equals 1, those can't be my answer. And so really I wouldn't have to do the check so much then, because when we got down here to the bottom, when we had that x equals 0, we would have automatically said, no, it's not in the domain, it can't be it. So 3 would have to be the one that works. Okay? I think that's a little bit easier. Y'all are pretty good at finding the domain now. So that's the route I'm going to use. Y'all okay with it? All right, so let's try that on example 4.